Alright, so now that we've looked into using the substitution method, we're going to look at the next method, which is called the elimination method. So we're going to begin with a quick example. We have two linear equations. The first one is negative 2x plus 3y is equal to negative 16. So this is equation 1. Then my second equation is 2x minus 3y, minus 5y is equal to 24. Now, the idea with the elimination method is that we want to add both equations, but by doing so, we must cancel out one of the variables. So one thing that we can notice right away is 2x and negative 2x are opposites of one another. So the goal is to do that so that you can cancel out terms, well, a variable. But that's going to be too easy. So what I want to do instead is cancel out the y's. So we have a positive 3 as a coefficient for the first equation, and we have a negative 5 as a coefficient for the second equation for y. Now, we want to look at the LCM of both of these numbers. What's the least common multiple that they share? And that value is going to be 15. So, I'm going to rewrite my first equation. And I'm going to write my second equation on the bottom below it. Now, we want to get y in both equations to be 15 and exact opposites of one another. So notice that in the first equation we have a positive value, and in the second equation we have a negative value for y. So we're going to multiply the top one by a positive 5, and we're going to multiply the bottom by a positive 3. We're just going to distribute that to each term. So we have 5 times negative 2x, that gives us negative 10x. And below I'm going to write down so we can follow along. This is equation 1, this is equation 2, and right here we have the result for equation 1. Then we have 5 times 3y, that gives us positive 15y. We have 5 times negative 16, that gives us negative 80. And below we have 3 times 2x, that gives us 6x. We have 6 times negative 5, that gives us negative 15y. Then we have 3 times 24, that is 72. And now we want to add both equations. So notice right away that we can cancel out these two values. Alright, so now we have negative 10x plus 6x. And we end up getting a negative 4x. Now we have negative 80 plus 72. Negative 80 plus 72 gives us a negative 8. Now we want to solve for x, so we divide by negative 4 to both sides, and we get x is equal to positive 2. So we found our first solution. And just like in substitution method, when we find our first solve for one of the variables and get a pair of this one of the solutions, we want to plug that back into either equation and solve for the next variable. So we're going to do it to the top one. So I have negative 2 times 2 plus 3y is equal to negative 16. Negative 2 times 2 gives us negative 4 plus 3y is equal to negative 16. We want to add by 4 to both sides. And then we get 3y is equal to negative 12. We divide by 3 to both sides to solve for the variable, and we get y is equal to negative 4. So remember, since we got a solution, our solutions are expressed as ordered pairs. So our first value was 2, and our second value, our y value, was negative 4. So we have our solution is 2 comma negative 4. And with that, we use both the elimination method and the substitution method. Thank you very much.